So we are going to solve equations and inequalities in one variable. So we are going to take a look first off at basic solving equations. If we can solve equations, we can do inequalities. So here's maybe just a basic example of a rational equation. The one thing that we want to keep in mind when solving a rational equation is that perhaps you're going to get things that are extraneous solutions. Those are answers that you'll get that are not going to work in the equation. So in other words, when you solve and you get an answer, make sure to plug it back in, check, and make sure that it works. So we're going to look at this first equation, and if we want to add these two things together, we want to think common denominator. So common denominator that we will have is going to be x minus 4. So I didn't have to do anything to the second fraction, so that means the numerator doesn't change. And I always think whatever I do to the bottom of the first fraction, which was multiplied by x minus 4, I have to do that to the top. So I have to multiply that by x minus 4. Okay, so that means we have x times x minus 4. So we're going to simplify these. So distribute that first fraction. So we're going to have x squared minus 4x. And I'm not doing anything with the second fraction. And now once the denominators are the same, I can combine the numerators. So by combining the numerators, we get something that looks like x squared minus 4x plus 1 all over x minus 4 equals 0. And so to solve something like this, we're thinking, when is a fraction equal to 0? So a fraction is equal to 0 when the numerator is equal to 0. So I'm going to set that equal to 0 and solve. And so in order to do this, we're going to have to use the quadratic equation. So if I plug this in, I'm going to have a negative b plus and minus the square root of b squared minus 4ac all over 2a. And if we simplify that down, we're going to find that x is equal to 4 plus and minus 12 over 2. I'm sorry, square root of 12. And if we simplify that a little bit more, we're going to find that that's going to be 4 plus and minus 2 radical 3 over 2. And from here, I can reduce everything by a factor of 2, giving us our final answer of plus and minus the square root of 3. Now, as far as checking for extraneous solutions, what we would want to do is take our values, plug them back in, and make sure we don't get perhaps a 0 in our denominator. So plugging in 2 plus the square root of 3 or 2 minus the square root of 3 into this denominator will not cause a 0, so both of those could be our solutions. Okay, same idea for this one. It's just now we have 3 fractions to work with, and really it's going to be the same process. We need a common denominator. First thing I would do, though, is take a look at this one, and I would expand this out. If I factor this out, we're going to see it's x minus 1, x minus 3, which is really nice because that would be our common denominator on the left-hand side. So common denominator is x minus 1, x minus 3. And I like to write my fractions separate for now until we work with the numerators, and then I can start to combine and solve. Okay, so the only fraction I haven't had to change has been the one on the right-hand side, which means the numerator doesn't change. Now, when I take a look at the first fraction, in order to get our common denominator, I had to multiply it by x minus 3, which means the numerator is multiplied by x minus 3. When I look at our second fraction, I had to multiply that by x minus 1, which means our numerator is multiplied by x minus 1. Okay, so that means if we distribute this through, I would have 2x squared minus 6x. For our second fraction, I would have x minus 1. Okay, so now that our denominators are the same, that means I could combine everything. So I would have 2x squared I have a negative 6x, positive 1x, so I have a negative 5x minus 1 all over our common denominator. And it's going to equal 2 over the common denominator. So at this point, we want to be able to solve for our value of x. So looking at this expression, I'm trying to make our two fractions to be equal. Well, our denominators are already equal. So what that means is, let's focus in on the numerator aspect of it. If I can set those equal and solve, that would determine a value of x that would give us two equal sides of the equation. So we're going to take that 2x squared minus 5x minus 1, set it equal to 2. And now for something like this, we're going to have to bring everything over to one side of the equation, set it equal to 0, and then factor. So we have to do a little hard trinomial factoring, meaning copy that first term, copy the last term, and then I want to find two numbers that are going to multiply to be negative 6, and it's going to add to be negative 5. And the numbers that we're going to be using here are going to be negative 6 and a positive 1. So I would have a negative 6x and I'd have a positive 1x. Okay, so we factor by grouping. And out of our first factor, I can pull out a 2x, which is going to leave me with x minus 3. Out of the second, I can pull out a plus 1, which is going to leave me with x minus 3. And we are going to gather our terms on the outside, write down our repeated factor. So now we factor that. And now to find the zeros, we can set these each equal to 0 and solve. So this one is going to give us x is equal to negative 1/2. And this we would solve and find x is equal to 3. So now we have to check. And we have to check for our extraneous roots. X equals 3 is going to give us an issue. If I try to plug in a 3 into here, I'm going to notice that that's going to give me a 0. And 0 times anything is 0, which means our denominator is 0, and that is no good. So we're going to get rid of that. That would be considered an extraneous root. So the solution to this problem is going to be x is equal to 1/2, negative 1/2. So that's when we have polynomial equations. We're solving rational equations. Okay. What happens when we have an inequality? Well, an inequality can be anything greater than, less than, greater than 0, less than or equal to 0, could maybe be not equal to 0. And what we want to do is basically try and figure out when the function is maybe greater than 0, in other words, positive, or sitting above the x-axis. And then we want to solve for when it's less than 0, or negative, or when it sits below the x-axis. And kind of big thing here, if it is a product, we can determine its sign by determining the sign of each of its factors. So we're going to see that on the back, see what that actually means. Okay, so on the back, here's our function. And if I want to try and solve, if we look at C, we're trying to solve for this function to be greater than 0. That's our goal here. So what we're going to do is try and follow these steps to kind of help chart this out and see where is this function actually just going to be greater than 0. Step number 1, we want to determine the real number values that cause it to be a 0. In other words, in this case, set each of the factors equal to 0 and solve. So if I set x plus 3 equal to 0, that tells me I could have a 0 at negative 3. If I set x squared plus 1 equal to 0 and solve, that's actually going to show me those are imaginary zeros, so I'm not going to get anything on the number line that I have to worry about. If I have x minus 4 equaling 0, I'm going to have a solution of 4. Now it is squared, so what that means is it's a repeated root. Okay, so I'm going to take those two zeros that we have, a negative 3 and a positive 4, and place them on a number line. And above those numbers, I'm going to write 0, because I know that that's a 0. Now it says we want to determine when this is positive, sitting above the axis. So what I would do is say, let's pick a point. Let's pick a point on any of the intervals, and we're going to plug it into each of the factors. So let's just try 0. 0 is always a nice one to start off with. So if I plug 0 into this first factor, 0 plus 3, that's going to give me something that's positive. 0 squared plus 1 is also going to give me something that's positive. 0 minus 4 is negative, but when I square it, it turns positive. So if I think positive times positive times positive, that means this whole middle section of my graph is positive. Now we can do the same for each section. So if I took, let's say, for instance, a negative 4. So plug it back in here. So negative 4 plus 3, that's going to get me a negative value. Negative 4 squared is positive. Plus 1 is still positive. Negative 4 minus 4, that gets me a negative value, but I have to square that factor. So if I square a negative value, now it becomes positive. So if we look at all of these, I have a negative times a positive, which is a negative, times another positive, which is still negative. And for our last section, so I'm going to take something that's above 4, let's take 5, for instance, and we're going to plug it back in. So I'm thinking 5 plus 3, that gets me 8, that's a positive factor. Go to our next one, 5 squared is positive, plus 1 is still positive. Go to this factor, 5 minus 4 is 1, squared is still positive. So when I look at this, all of these values here are positive. So if I want to write the solution now to this problem, it's saying tell me when the function is greater than 0. In other words, where it's positive. All right, so we're going to write this in interval notation. So where is this greater than 0? Well, it starts at negative 3, but it can't include negative 3 because that's actually equal to 0. And it goes out to 4, but again, it can't include 4 because that's equal to 0. And then on the other side of 4, it's also going to be positive. So in order to solve an inequality like this, we want to think to ourselves, find the zeros, place them on number lines, do our positive-negative test, and then we can answer the question. Okay. So those are polynomial inequalities. The only thing that changes is if we get a rational inequality. And really, it's not going to change that much. It's the same idea. It's just how we solve for it and what we're solving for. So looking at our function, r of x, we have to determine, number one, the values that would make it 0. Okay, so to find our zeros, well, when a fraction is 0, that means your numerator is 0. Set that equal to 0. And if I solve and find, x is going to equal negative 1/2. So just like we did before, I'm going to place it on a number line. And I know that that's 0. Now we have to find the places that would make it undefined. Well, our denominator, when that's set equal to 0, that would tell us where it's undefined. So that means at negative 3 it's undefined, and when x is 1 it's undefined. So I'm going to do the same thing on our chart, but this time I'm going to write the word, or maybe the abbreviation, UND, undefined, just so that I know that that's actually not a value there. That would be like having an asymptote. Okay, so now for letters C and D, it says figure out where it's positive or where it's negative. All right, well, we're going to do the same kind of test that we did before. We're going to take a value, plug it in, and we're going to then divide it out and figure out positive or negative. So again, I'm going to start with 0. So 0 is in this section right here of our number line. And I'm going to start with the numerator. So if I did 2 times 0 plus 1, that gets me a positive numerator. If I go to my first factor, 0 plus 3 is positive. If I go to my second factor, 0 minus 1, that's negative. So on our denominator, positive times negative, I see that would be a negative number. If I divide the fraction, positive divided by a negative, we get a negative. Okay, let's stay on the positive side. Let's maybe pick 2. So we'll focus on that side of our graph. Okay, so working in the numerator, so I have 2 times 2 is 4 plus 1, so that's a positive numerator. Let's go to the bottom, so I'm going to have 2 plus 3 is positive. Second factor, I have 2 minus 1, that's still positive. So that means this whole section over here has to be positive. Okay, let's work in between the -3 and -1/2. Maybe we'll think of, how about -1? So again, go back to your numerator. So 2 times -1 is -2 plus 1, so our numerator would be negative. On the bottom, if I have a -1 plus 3, that gets me a positive factor. I have a -1 and a -1, that gets me a -2, so that gets me a negative factor. So multiplying the bottom, positive times negative, I get a negative. Now divide the fraction, negative divided by negative, I get a positive. And the last one, so maybe we'll try -4. Think of -4. 2 times -4 is -8 plus 1, so my numerator is negative. Okay, over here I have -4 plus 3, that's a negative. I have a -4 minus 1, that's a negative. So now we're going to simplify. So if I have a negative times negative, that's a positive. So as our fraction, I have a negative divided by a positive, gets me a negative. So now we've done our negatives, we've done our positives. We're going to write the solution to the problem. So I want to know, where is this function either greater than or equal to 0? Okay, so the first section of the graph is negative, so that's not going to work. 3 is undefined, that's not going to work. But now I start with something positive. That's a greater than section. So I can't include -3, but we're going to start there. And we're going to go to -1/2, and I can include -1/2 because it equals 0. But I don't want that next section because that's negative. So I'm going to put a U to join it, and I can't include the 1 because it's undefined. And then I go out to infinity. So this is answering the question, where is our function going to be greater than or equal to 0? We will do more with this in class. We will try some other functions in class, but I hope this gave you a good, solid basis to start.